Okay, so today we're going to talk a little bit about literal equations. So before we get to the actual definition of a literal equation, I want to make sure that we understand when we talk about an inverse operation. Remember, inverse just means that the opposite, right? So the inverse of multiplication is division. Okay, and then the inverse of division is multiplication. Okay, the inverse of addition is subtraction, and the inverse of subtraction is addition. So you guys already know this because we have been using inverse operations when we're solving. Okay, so today we're going to talk about a special kind of equation, and that is a literal equation. What makes something a literal equation is there's two or more variables in the equation. So kind of looking at number one, we're going to compare them side to side. Okay, so we're going to go through and we're going to solve a one variable equation. Okay, and what we're going to do is we're going to, just like we've been doing, we would add 7 to both sides. Right? So I get 5x is equal to, and notice you're able to go ahead and combine these because these are like terms. They are both constants. Okay, and negative 27 plus 7 gave us negative 20. And then we would do the inverse operation of multiplication. We would divide by 5. Okay, and again, we're able to actually divide these out because these are both like terms. They're just regular numbers. So then x is equal to negative 4. Now in a literal equation, notice what happens. Okay, we're still going to, in this case, we're going to try to get x by itself, just like we did here. Okay, but there's something different. When we go to perform the inverse operation, right, so I'm going to subtract y, okay, and don't get thrown off because it's a y. If we're adding y, we're going to subtract y. Okay, that leaves me with a 5x. Notice I can't do anything to these because these are not like terms. Okay, so what I'm going to have is z minus y. Okay, and so the next thing is I would do the inverse of multiplying by 5. So I'm going to divide by 5. And notice I can't do anything with this, right? I don't know what z divided by 5 is or negative y divided by 5 is. So this is going to be my answer. X is equal to z minus y divided by 5. Okay, look at number 2. Again, don't get thrown off because there's no numbers in there. Okay, so we're trying to get the triangle by itself. Okay, so right now in order, so the smiley face and the triangle are being multiplied, and then a heart is being added to it. So we're still going to perform our inverse operations. First, we're going to subtract the heart. Okay, because the inverse of adding is subtracting. Okay, so right now I just have a smiley face and times my triangle is equal to my lightning bolt minus my heart. Guys, I can't do anything with this. Okay, I can't combine them. So now the inverse of multiplying by a smiley face is dividing by a smiley face. So I'm dividing by a smiley face. These cancel out, and you notice what's going to happen is this is my answer. I can't simplify this anymore. So in a literal equation, your answer is not going to be triangle is equal to 7. It's going to have the other variables in there. So my answer is triangle is equal to lightning bolt minus heart divided by a smiley face. So we're essentially just undoing everything that we have done. Okay, it's asking me to solve for h on number 3. All right, so first thing is I've got to figure out what is on the same side as h. So right now this is saying L times W times h. Okay, so in order to cancel these out, I have to do the inverse. So I am going to divide by L and I'm going to divide by W. I can divide by them at the same time. Okay, so since h is being multiplied by L and W, I'm going to divide both sides by L and W. So that's it. H is equal to V over LW. All right, let's look at this one. Okay, so I'm going to solve for A. All right, so remember, my goal is to get A by itself, which means I have to undo everything that was done to that side. Okay, so the first thing is A is being multiplied by 7, and then B is being added to that. So I'm going to get rid of this B. So if B is being added, the inverse of that is subtracting. And guys, I'm going to write it down here. Okay, but notice I do not have any other like terms. So I'm going to leave it as 2C plus D minus B. Okay, I can't subtract B from a C or a D because they're not like terms. And then if A is being multiplied by 7, I am going to divide by 7. Okay, so my answer is A is equal to 2C plus D minus B over 7. All right, let's look at number 5. So again, I'm solving for y. So I'm asking myself, what do I need to get rid of? Okay, and again, I know it seems a little bit more confusing because there's no numbers, but we're still doing the same operations. So the first thing I'm going to do is I'm going to get rid of this whole thing. So guys, this is a positive ax. Okay, so the inverse of a positive ax is to subtract ax from both sides. Okay. Now notice I can't combine these on this side, so what I'm left with is by is equal to c minus ax. Okay, now y is being multiplied by b, so the inverse of multiplying is dividing. So I'm going to divide both sides by b, and I'm left with y is equal to c minus ax over b. All right, number 6. So I have A is equal to 1/2 BH, okay? And I'm solving for B. So the first thing I'm going to do is I'm going to get rid of this 1/2. Okay, so remember we can get rid of this 1/2 by multiplying by the reciprocal. So if I have a 1/2, I can just simply multiply both sides by 2, because remember 1/2 just really means that it's being divided by 2. So I can multiply by 2. Okay, multiply by 2. So my 2's are going to cancel out, so I have a 2a is equal to bh. Okay, and then if I'm trying to get b by itself, it's being multiplied by h, so I just need to divide both sides by h because that is the inverse. So h is equal to, b is equal to 2a over h. All right, just a couple more, guys. All right, so number 7. All right, so I'm trying to solve for v. Okay, so I have d is equal to m over v. Okay, so this is going to be kind of one of those special cases. So right now I'm going to get v over here, and then I'm going to get d over here. Okay, so if m is being multiplied by v, I'm going to multiply by v. So these are going to cancel out, and I have d times v is equal to m. And notice now, if d is being multiplied by v, I can divide by d to get it to the other side. So v is equal to m over d. All right, number 8. Okay, so we're solving for a, so don't get thrown off by the exponents. Okay, right now all I know is I have an a squared plus b squared equals c squared. If you guys remember, that is your Pythagorean theorem from last year. Okay, so right now b squared is being added to a squared, so I need to move b squared to this side. So I'm going to do the inverse by subtracting. And notice I can't combine my c and my b, right? So it's just going to be c squared and b squared. So this is one of the things that I need you guys to make a note of. So the inverse of squaring something, okay? The inverse of squaring something is taking the square root. So if you have a squared, the inverse operation of that, to get rid of that, we need to take the square root. So if we take the square root of something, we have to do it to the other side. So this squared and this square root cancel each other out. You're just left with a equals the square root of c squared minus b squared. Okay, so on this last one, we're going to look at this equation to start with. So we're going to look at y equals mx plus b. Okay, and then we're going to go ahead and solve that for b. Okay, and look at that. So remember, if I'm solving for b right now, mx is being added to b. So I just need to subtract mx from both sides. Okay, so that's going to leave me with y minus mx is equal to b. Okay, so here's what we're going to do. We're going to, they tell me in the question, if m is 4, x is 7, and y is 30, what is the value of b? Okay, so I can do this a couple of different ways. I can just plug in what I have. So I know y is 30, okay, and I'm just plugging it into the original y equals mx plus b. I know m is 4. I know x is 7. Okay, and I don't know what b is. Okay, so again, if you're wondering where those numbers came from, so my m, just plugging it into the original equation, is 4. My x is 7. Okay, and then my y is 30. Okay, so if I go to solve this, I have 30 is equal to 4 times 7 is 28 plus b. And we know from solving this, I would subtract 28 from both sides. And b is equal to 2. Okay, and notice what happens, that even though I rearrange this equation, if I go ahead and I plug in those numbers, right, so y is still going to be 30, m is still going to be 4, x is still going to be 7. Right, so if I have 30 minus 4 times 7 is equal to b. So notice what happens, 30 minus 28 still gives me b is equal to 2. Okay, so sometimes it's just helpful to have your equation rearranged so that if you're wanting to solve for a particular value, okay, you don't have to do a lot of the rearranging that we did here. Just make sure you guys have all of this written down.